concerned with. The first one is how the files and directories are stored. So, how do we keep track of which file is stored into which disk block? So the disk is divided into blocks, and we can store one file in one block, or the file can take multiple blocks depending on the size of the file. So how would we keep track of which file is stored into which block? Because this is what the operating system needs to do if we need to implement the file system. So we have a bunch of disk blocks, and each file can take one or more blocks. The simplest way to do that is called contiguous allocation of disk space, which means if the file takes one block, then good, we'll put it in one block. But if it needs 4, then we assign 4 blocks contiguous, which means they're next to each other for that file. So we know after the first block ends comes the second block of the same file, and so on. This is the easiest way to do it. It's the simplest scheme that we have. Store each file as a contiguous run of disk blocks. So this is simple to implement because this is the advantages. It's simple to implement because since the blocks are right after each other, then the only thing we need to store is the first block and the number of blocks that are following the first block. And this way we have the information about the first file. This way we know all the blocks that make up the first file. So the only thing we have to store is where it starts and how many follow after that. In this case it starts here and 4 blocks are following up. Total number of blocks. Another advantage is the read performance. We can read the entire file in a single operation because they're all next to each other, so it's easy to start reading from here and go to the next and to the next block. For the disk arm, so the disk arm doesn't have to move too far away to get all the blocks of the file, so this is good for performance. you think of any disadvantages of this method? So remember, we are managing the disk space. We are storing the files, and then we're keeping track of free blocks. So we have files, free blocks, files, free blocks. Do you see any problems with that? Maybe anything similar to the memory management? You guys remember what happened when we did segmentation? So we would put one process in one segment and then remove it from there to insert another process. Do you remember what was the issue with that? What would happen after some time? Yeah, so we have more holes, and we probably have smaller and smaller holes that we could not fit a process in, right? So we would have, and we had to do defragmentation, right? So we will compact the segments together and the free space together. So we have one big chunk of free space. So the same situation happens with RAM, happens on the disk where we store the files. So if we're using this method, we're keeping track of holes, free space, and use blocks by using either the bitmap or the linked list that we have seen already in the memory management. So we would eventually have to delete some of these files. Either user ran out of space or user doesn't want these files anymore or made a mistake, and so end up deleting some files. And if they do that, let's say this file B was removed from here, right? So these three blocks are now free. And then we try to store a bigger file C in there, it wouldn't fit in there. So we have to leave that free space and go looking for a bigger chunk of blocks so where this file will fit in. And after creating and deleting more and more files, after some time we would end up with a bunch of small holes that it's hard to fit anything in, and so we're creating fragmentation in this way. So disadvantages of this method is fragmentation. So this has been widely used with, are there certain disks that we know the size of the files before we start writing them on the disk, and then they never change after that? Do we have such disks?
Maybe the BIOS, but everything else. Everything has an update, so it will get bigger at some point.
Well, not long ago we used to use certain disks to record music and files on them and backups.
Oh, yeah. Yes.
Right? The CDs?
No one uses those anymore.
No, but it was used a lot, and this was the primarily file system arrangement for these disks. So the CD-ROMs use this method to organize the files once recorded and that's it. So we knew the size of the files or whatever we record on them and then did not change them anymore. However, if we want to be more efficient, we could use a linked list method allocation. And in this method, we are not placing the files into blocks that are right next to each other. So if one file is too big to fit into a single block and has to be placed in multiple blocks, if we want to avoid the fragmentation issue, what we can do is, instead of having the file start here and then use all the rest of the blocks that follow, we would just use any free blocks that we find on the disk. And within each block, we would reserve a small space for a pointer to show us where the address of the next block that follows. So each block will have a pointer to the next block of that file. So we would store them in a linked list in this way. Keep each file as a linked list of disk blocks. The first word of the block is used as a pointer to the next block. In the last block of the file, the pointer is null, which means that there are no more blocks to follow. And so the advantages of this method is that we don't have fragmentation. So we are efficiently using all the free space on the disk. If we have one block free, we can use it. But are there any disadvantages of this method? So are there any disadvantages? So these blocks are anywhere on the disk. So a file could start here and the next piece is far away and the third piece is close again and the fourth piece is far away again. Is that a good idea? And let's say the disk is divided like that. And the disk arm is here. And it's reading a block from here. And then the second block is over here. So it has to move to get that. then the next block is over here. So it has to move to get that. See, if they were all in the same place, like we did in the previous algorithm, we could access them very fast. Because we didn't have to move around through the disk to get all the different bits and pieces of the file. But now we do, so what is the disadvantage here? Is this gonna be faster than the previous method or slower? It will be slower, right? So random access of disk is slow. So what can we do? How can we speed that up? This is on the disk. Disk is not the fastest memory that we have. Do we have faster memory than the disk? Do you guys remember the memory hierarchy? Disk is big and slow and cheaper. And then we have what? The RAM. The RAM is smaller, it's a little bit faster, and it's more expensive, right? Then we have cache, and then we have registers in the CPU, which are the fastest and the smallest and the most expensive, right? Ideally, we want to have the whole memory consist of registers, but we can't, because nobody would be able to afford such computers. So, to speed up this random access of blocks on the disk, remember the disk is an I/O device. Every time our process or code needs to read something from the disk, we are doing an I/O operation, which means the process has to stop running until the CPU is given to another process until the I/O operation is complete. And if we're going to read the file and have to go to the disk to read that pointer for the next piece of the file every time, that makes our process very slow. So what we can do is we can try to load some of these pointers into the RAM, in a table in the RAM, and the access to the pointers will be much faster if they are in the RAM than going to read them from the disk every time. Remember when we talked about segmentation and paging, and we did that exercise, and when the page was not in the RAM, we had a page fault, which means the page is on the disk and we have to go and get it. But that's slow, so we have to wait for that. We have the same situation here, so if we try to load these pointers into the RAM, we might speed up the reading of the files. So we could use the linked list and create a table in memory to show in which blocks the parts of the files are located.